Hi guys! Today we're going to explore the wonderful world of optics with curved lenses and mirrors. This video will entirely be about shapes and how you want to simplify the language and terminology. So there's only two, so it already starts out pretty simple, and that's concave, convex. So the way I do it is, well, I look at the word cave. Concave means it caves in toward the object. So if I have some object here, like person, the mirror or lens will cave toward the person, and if it's a lens, you're going to get that the cave shape will repeat on the other side because a lens is two ways. So if I have the object over here, it would cave toward it that way. If I have an object over here, it caves toward it this way. So what I like to do is I like to draw little hashes to mean that this is the not shiny side. So this is the shiny side, this is the not shiny side. So this is a mirror, this is a lens. You can always tell a lens because it works two ways. You can always tell a mirror because it only works one way. And then of course, there's no clever way of remembering convex except that I actually have a very clever way. Oops, my person has no face. There he is. The way to remember convex is it's the opposite. That's simple, right? Simply vexes away from. Is that a thing? Could be. And vexes out versus caving toward. So remember, this is the not shiny side. In other words, this would be the rough side of a mirror that does not reflect light. And this would be the side that does. So here the light's going to bounce off. Here the light's going to bounce off. Here the light will pass through. So what does a convex lens look like? Well, to draw a lens, you draw the vex shape, and then you draw it again. As if there was an object over here, it wouldn't cave towards it. This is the caving toward, and this is the vex. So the important thing to remember here is that these each have what's called a focus. Pay very close attention to where I'm drawing focus. It should make a whole lot of sense. It's not a complex process. It's a very simple process to determine where the focus is. What's very important is I'm assuming light is coming from the left hand side. For all of these. Notice the pattern here. Notice how the shape wraps around the focus. So I'm not looking at this end for the lens because that's not the side of the lens that's being used. This is the side of the lens that's being used. In fact, what you can do is even have a lens that's shaped like this, and this is also a convex, careful. This is a concave because it caves around the light. And this would be a convex lens. If you have the other side shaped in the same fashion, of course you can use it both ways, which typically is the case. So the distance from the focus to the lens or mirror is called little f, and it's to the center, that center line. And that is called the focal length. The distance to the focus. So the last important part is that this curvature you can think of as being part of a circle with some sort of radius. Ooh. And it turns out, I didn't draw this very well, I apologize, that the radius is twice as far out as the focus. So I did not do a good job of drawing this. I apologize. I'll draw it better for you guys in class, but the whole thing you want to remember is that the focus is half the radius of curvature. There's a reason why I'm erasing these. I want to get rid of the clutter here. So our focal length is half the radius of curvature, and there's geometric reasons as to why. I'd rather not get into it now. Just remember that as a thing. We can talk about that in more detail. So the last important thing is that the light, after it interacts with the mirror or lens, as you guys are drawing in your homework this weekend, will be either reflected or refracted by the law of reflection or refraction. So, as you guys will notice, a concave mirror will reflect the light such that parallel lines will always go through the focus. Notice how the convex, the light cannot actually go through the focus in the real sense, so you imagine the line being drawn back, and that extended line, will go through the focus. So this convex mirror will diverge the light, the concave will converge it. So notice how for a concave lens, the light must go through. So will it go this way or go this way? Well, remember, it has to go through the focus, but it's not going to reflect. It's got to pass through. So it's got to pass through such that it refracts that way. And you will confirm that by looking at this boundary. In this boundary, drawing the normal line for all of these as you should. And you'll notice that it will indeed bend outward. And we can draw the one down here. So the easy thing to remember is the shape is determined by the name, which determines where the focus goes. And then knowing that light always passes through the focus, either in a literal, real sense, if it reflects, or in a imaginary sense, in this case. But of course, the imaginary reflection here, or the reflection means the imaginary path must pass through the focus for a convex mirror. Of course, last but not least, we have a lens in the convex shape, and since it refracts through, we can draw that going directly through the focus. So that completes it. Notice how there's a very important thing here. We want to sort these in one of two ways. We want to sort it by converging and diverging. So once you get this down, which is converging? Clearly this and this is converging. So the converging are the concave mirror and the convex lens, because the light literally goes through the focus. And of course, these two diverge the light, because the light must pass through the lens and it must bounce off the mirror, but the curvature says the focus is on the opposite side of where the light is. Therefore, imaginary lines must be drawn back. And we say that, well, we can see that the light is pulled apart. It's diverged. So for a converging mirror, converging lens, it's those shapes. For a, I'll draw the mirror first again. You can imagine this splitting the light apart, and of course this is always a famous one, just knowing that the hourglass shape is a diverging light. I wonder if this will help. I'm going to do an experiment here. Drawing the lines might help. I think this helps a little bit, get an idea. And the picture is complete. This is the first step, understanding the geometry. Of course, it would be a great idea to draw this beautifully in your notes. Keep it simple. Once you have the converging and diverging down, and understand that cave is this and vex is this, and of course it's opposite for mirrors or lenses, everything ends up being very simple, And we'll explore that and the mathematics of the lens and mirror equation next.